Welcome back to the series called Troubleshooting 101. Today, basic audio. Now, we're going to be talking about basic audio today as a part of our Knowledge Basics series, and I am Bruce Gilson, and thank you for joining us for this series. If you haven't watched the other videos, make sure you go check them out about video systems and distributed audio systems and lighting systems, but most importantly, make sure you watch that video on the introduction to prints and system flow. That is the one we're going to be building on today. Today we're looking at basic audio. Now, let's be honest, audio can have a lot of problems. Now, I'm an audio guy. I'm not trying to hate on you audio guys. This is just the reality is it can have several different problems and I can't cover everything in one video. So really what we're gonna cover today is a buzz, okay? That's the most common problem that we have in audio is that there's a buzz that has introduced itself into the system. So our basic system today, we've got a microphone, we've got a mixer, we've got our distributed cables, which are most likely XLRs, going into our amp, and then the amp has distributed cables going out to our speakers. And guess what has happened? That's right, Mr. Buzz himself has shown up in our speakers and we've got a problem, all right? So how do we begin to troubleshoot this problem? Well, if you've been in our other videos, I am trying to stress with you guys, start with the problem. So let me tell you why buzz normally happens, okay? In this system, the basic system was a microphone, mixer, amp, and speakers, but the amplifier requires power and the mixer requires power. And I went ahead and threw in a guitar amp over here because guitar amps require power. Now, these three different elements of power, when they combine into one system, I know this sounds weird, but there's a thing called impedance and a ground loop and a ground hum. And if you've been around audio long enough, then you're familiar with what I'm talking about. But essentially what happens is if this power is different than this power and this power is different from that power, there's a differential impedance between the types of power. And if there is, they will cause a buzz with each other. That differentiation in impedance will cause a buzz. That's the number one problem. And most people say, well, it's dirty power. And they're not exactly wrong. It is dirty power. But what is dirty about the power is that it's coming off of different grounds. This amp, let's say it's located in an amp rack room on the second floor and it's far away. And then this mixer is on the first floor and it's at the front of house. And this guitar amp is on stage and that's another far away. And if those three different elements weren't combined to the same ground in the building, then that's gonna cause a buzz, all right? So that's the number one problem. Now, that didn't teach you how to troubleshoot the problem. So the way to troubleshoot the problem is to start eliminating elements to isolate the ground. So in this particular example, my speaker was buzzing. My speaker's connected to my amp. If I go and I disconnect my input to my amp and the buzz goes away, well then I have a good idea that my buzz is happening somewhere between here and there. I could also take a different input and put it inside my amp. Maybe I take my cell phone and I figure out how to put my cell phone straight into my amp through an adapter. And if that's all working, well, then it's not the amp that's causing a buzz. Now, I will say, if on the power circuit that your amp is coming off of, if somebody else in the building connected to the same ground has decided that they would like to make margaritas, and they've got a margarita machine just doing the cha-cha, all over your power over here, when you disconnect this, that margarita machine's still gonna do the cha-cha and you're gonna get a buzz to your amp. And now you know you have a dirty power problem specific to your amplifier. But if it doesn't happen, this gets clean when you disconnect this and you reconnect and the buzz comes back. Now we've got a problem somewhere between here. So my mixer, what I can do is I can trick these lines that are coming off the mixer and I can put an input bypass the mixer. If you're gonna do that, I highly recommend using a battery operated input, okay? Like if you took your laptop and you don't connect it to power, you're running off your laptop's battery and you put it in, your 1/8 inch jack out to an auxiliary and you send a signal down the lines that used to be connected to your mixer. The reason is when you're running off a battery, you're not connected to the ground. So by doing that, I'm isolating the ground and I'm trying to identify, do I have a power issue or do I have a signal flow issue? If you're running off of a battery operated input, you've bypassed your mixer and you still have a buzz. Well, now you know you have a signal flow problem. You don't have a ground problem. If you plug in your laptop and it all works, it's highly probable that you do have a ground problem between these two elements, okay? Now, we could also have a problem with this power, this guitar amp. You could potentially have a problem with this ground. And when you get into this world, I've got a DI here. DI stands for direct input. A direct input oftentimes has a ground lift button on it, a switch. And the reason it's got a ground lift is trying to disconnect the ground from this power source to this power source to eliminate buzz. All right, so that's a really easy way to try the ground lift on there. Check your mixer if your mixer has a problem. Now you might be saying, Bruce, okay, you told us what the problem normally is. How do I fix it? Well, this does become a challenge if you're in a venue that has dirty power, where you've got a differential of impedance in these two grounds and it's causing a buzz in that. My first recommendation is to try to put a battery backup system at front of house that connects your mixer. If your battery backup system doesn't work, you're putting it on like a UPS system. If that doesn't work, then you're gonna have to convert this signal from analog to digital and then back into analog in order to get rid of the ground, because digital doesn't carry a ground buzz. All right, this is a part of the video where I share a little bit of stories about my experiences of troubleshooting. I actually wish I didn't have so many stories about buzz in audio. I mean, the reality is it happens all the time. Looking at you, churches, I love you, but boy, have I spent a lot of time trying to chase power. In a lot of ways, every time you turn on a sound system, there's a buzz. So this is something you have to do a lot, but I've got a couple of big stories for you. Number one, we installed a large event space that had these huge, it had like 210 degrees of shades around the event space on motors. And in the pre-planning process, we had asked for an isolated AV panel, which means our audiovisual panel shares no power with anything else. It's all by itself in its own panel, and we got denied. And the trick that they used was a trick that I mentioned a little bit earlier in the video. They converted the analog audio into digital audio, and then they transmitted it over to the amps, and then they converted it back from digital into analog, and that actually prevents your front of house audio carrying a buzz because of differential of impedance over into your amp rack room. So that part that they did correctly. And if you want more information about that, we might make a little bit of bonus material on this digital analog conversion, but that's all I'm gonna say about it right now. So that's how they handled the problem that we weren't gonna get an isolated panel. But they put the motor shades inside the panel with the power for the PA, so for the actual speakers themselves. And it didn't get caught by anybody until the grand opening event. And in the grand opening event, they had all the shades closed because they wanted this big reveal of downtown. And they're in the event, PA's going, everything's closed, the lights are going, people are sitting and eating dinner, and then all of a sudden they hit the button to open the curtains and you got going through the PA. And instantly we knew it was because there was DC motors on the panel that didn't belong there. And so they just moved those motors to a different panel, problem solved. So not only is this such a common problem, but I was actually preparing for this video and trying to put everything together. And in between, I had a service call and I went out to a church and I was servicing some other problems that they had. But they said, hey, while you're here, we want to show you something. Whenever we turn on the house lights, the sound system buzzes. And I immediately said, oh, your house lights are plugged into the wrong panel box. And they started laughing. They're like, well, how do you know that? You haven't even looked at it. You don't even know. So they go over to the lighting console and they turn on the lights, and sure enough, it begins to buzz in the audio system. And I said it again. I was like, well, your dimmer packs or whatever's running your lighting is plugged into the wrong panel box. And the lady kind of looked a little bit confused and she was like, well, my husband and I installed the lights ourselves and we made sure that there's nothing else plugged into the outlet. What she meant was the physical outlet on the wall, but that has nothing to do with what ground it's sharing in the building. But on the wall outlet, it said P171. And so in this particular case, that meant panel 1, breaker 71. And I said, well, your entire sound system is gonna be inside panel 1. And she was like, well, how do you know that? And I said, well, because you're on stage, that's where you plug your dimmer packs in. All of the stage power should be in the same panel box. And I said, my guess is your performance lighting in the air is going to be in a different panel box. She said, well, I actually installed that too. That's in P4. And I said, well, all lighting should have been in P4 and all sound should have been in P1. That's how they're keeping the separation. It's almost predictable that, if you've got lighting, if you've got a margarita machine, you've got window shades, if you've got motors on the same panel or the same ground as your audio system, you're gonna have a buzz. So I hope you enjoyed that story time and maybe you learned something. If you did, or even if you didn't, but you're enjoying the content, make sure you hit like, hit subscribe, send me a comment, ask me a question, and I'll get back to you as soon as I can. Otherwise, we'll see you later on another episode of Knowledge Basics.